So home automation's been a hobby of mine for decades. I used to watch Tomorrow's World in the 80s and see those futuristic homes of the future with the gadgets and wished I had one. So back in 1989, at my student house, I set up my doorbell, connected it to an old 286 computer via the parallel port. We had a Novell NetWare network with coax cables running throughout our student house, and it was in a crate in the hallway. So the doorbell would ring, a message would pop up on every PC, or not. That message would pop up on every PC. And being students in a house, busy coding or gaming, we'd just ignore it. I've used old Windows medical tablets attached to the wall, running hacked Perl scripts for communication. But a few years ago, I moved everything over to Home Assistant. Home Assistant is a hugely amazing open source project that supports hundreds and hundreds of components and has a vibrant and healthy community. You can run Home Assistant on your local server, something as simple as a Raspberry Pi. I use a Lenovo ThinkCentre for mine, and some Android tablets on the wall for doing things like a local front end. But this talk is specifically about voice control, and for that I used Alexa together with Home Assistant. Now, Alexa didn't have to do very much. Timers, lists, blinds, the occasional moose joke. Amazon liked to store your voice recordings and use them to train things. You can turn that off, though. But what really broke it for me was when they turned off the ability to export your shopping list. They just changed the app. There's no export or share option there anymore. The only way you can give that list to someone else who's doing the shopping is to take multiple screenshots or have them install the app. I guess that's what you get from trusting a closed source ecosystem. So time to say goodbye to Alexa. So this is the story of my journey training a voice assistant with a personality. Local where possible, no local large language models, avoiding cloud AI where we can. Now, why am I not all in on AI? Firstly, I'm a little tight. I'd rather not spend a lot of money, one-off or monthly, just for voice control. But mostly, I'm retired, and I spend my days now doing security for the Apache Software Foundation. And over there, we've gone from getting maybe 50 vulnerability reports a month to, in the last month, over 800. That increase is mostly due to AI, and most of those reports are, well, invalid. So one thing we had to do was to figure out if we could use AI to handle those AI reports. So it's explained perfectly by this 15-year-old meme. We had AI write us a set of skills that we could use with an AI agentic workflow to generate answers to the vulnerability reports sent to us by AI. And at this point, it's less about fixing vulnerabilities and more about causing the prices of GPUs to spike. Seriously though, LLMs are useful, cloud services are useful. We'll just try and keep things as local, as cheap, and as privacy-focused as possible. So, since last year, if you want voice control in Home Assistant, you can just go and buy one of these things. The top left there, a voice assistant PE. Down at the bottom, a little tiny M5 Atom. There's also a little M5 Pyramid there. There's lots of others as well. They're all under about £60. They have an ESP32, mic array, audio processing, little buttons, LEDs. You can pick them up really easily. Simple, cheap, just works. A bit like Alexa, they're boring. So let's take a look at all the parts of a voice assistant. We're going to give it a personality. We're going to figure out when local is good enough. And more importantly, have a bit of fun with it. It's all open source. We can just take whatever parts we like, replace them how we want to. Here's the basic voice handling pipeline that you get by default in Home Assistant. You need to firstly listen all the time to the thing that wakes you up. That's like Alexa. Micro Wake Word does that on ESP Home on whatever hardware you've bought. Then you've got to record some audio and do speech to text on it. That's Faster Whisper running in a container on your home automation server. Then you've got to process that text, do some action, come out with some text, and then respond with text to speech. And that's Piper with eSpeakNG running in another container. And with the voice PE in my kitchen, with some 3D printed housing, it kind of works like this.
Jarvis, turn on the light.
And in all of these presentations, I've not shortened any of the sequences so you can get an idea of how responsive things are. Now, give you one.
Hey Jarvis, what is the temperature?
20.1 degrees.
I wish it was.
Hey Jarvis, close the blind.
Closing.
Now, while I live in Scotland, I've never picked up the accent, as you can probably tell. My wife, though, is Scottish, and she has huge problems with speech-to-text systems. Our old first-generation Prius sat navigation, she used to have to say, go home to it. It would always toggle the point of interest golf course. It's a common issue. Those that know the comedy show, Scottish comedy show Burniston, will be aware of the famous sketch. The two Scottish men are in a lift trying to get the voice recognition to tell them where they want to go, and they're shouting 11, 11, 11 repeatedly and getting increasingly frustrated with the lift telling them, could you please repeat that? That's foreshadowing. Let's start with an easy win then, custom wake words. With 3 wake words by default here, and that's because it's actually quite hard to get a word that works across all accents and is quite impervious to like false positives. Micro wake word I said was used on the ESP32 for this. It locally listens all the time and it looks to detect these words. But you can train your own model. You can just use a set of recordings of a wake word and a set of recordings of like fake background noise. And there's GitHub with Tater Totterson, who's done a lot of the hard work of making this really easy with some scripts. I just recorded 40 samples of me and my wife saying something that's not coming out. Hey Vicky, she says. I figured that was a reasonable name, pretty distinct, and the extra hey would stop false detections. Any idea why that's not coming out? Okay, hopefully on the next ones. It takes a few minutes to set up, spits up a web interface like this, you run the trainer and you wait. It's not very demanding, a couple of hours on this MacBook, it also runs on Linux and other systems. And at the end you get a JSON file and a TF-Lite file. You just pop them somewhere ESP Home can see them, a simple ESP Home change, you do a compile and install, it's all in the browser, does it all over the air, and then configure your voice assistant to say the new wake word.
Hey Vicky.
And then we can have it responding to us saying, hey, Vicky. Now, in my experience, this training didn't go perfectly. You can run debug in ESP Home and see how the detection probabilities are going, and then you can add this ESP Home change or something like it and change them on the fly. So rather than having to recompile all the end. Now, my scripts and all the links and all the code and things are on my Codeberg link at the end. It's actually quite funny to have Vicky interject whilst watching TV sometimes, but just sometimes. That's a quarter of what we need to do. Let's keep up the momentum and do another easy thing. Let's do a custom voice. So the default is to use Piper locally to do text-to-speech.
I have turned on bedroom light.
It's a phone-based system. It's super fast even on a Raspberry Pi. You can get super impressive AI voice models these days, which sound almost human, but you need high-end GPUs, CPUs to do those. Let's stick with Piper because it's lightweight, and it does come with many voices. People have trained other voices. You can have the sound of the computer from Star Trek or Commander Data.
15.0 degrees C and raining.
But we want something a little bit more endearing. And me and my wife both watch a lot of anime. So how about a custom anime-style voice? Let's say this is the prompt of the voice we're going to be looking for. With quite a few steps to make a custom voice. We're going to design a model using various AI tools. We're going to train a model that ends up using phonemes for eSpeak. I'm thinking that this is the meme from earlier. We're going to use AI to train a voice in AI, which we're going to clone in AI. Originally, I used to use 11 Labs for voice design, but there's now local free models you can use, and my favorite at the moment is Qwen3 TTS, which does a really good job. You write a little bit of Python, it takes a voice description, it takes a sample text, and it creates an output WAV file. And we've turned our original prompt into a more detailed description here that suits that model. My PC for training is a mid-range GPU 3060, so it only takes a couple of minutes to run this, and I'm worried this isn't going to work. It's not. Imagine an anime voice saying those things. This is a voice design model, so you get a different voice every time you run it. It's not designed that you give it a seed and you get the same voice when you try it again. We said here, gender neutral, we tend to end up with more feminine sounding voices. So let's use this one, the one you can't hear, and hopefully you kept a copy of the WAV file because you're not going to get it again. So next we're going to have to clone it. So we use a different model for this. We use index TTS2, and that can voice arbitrary text by cloning a voice. There's many other models available. I like to use this one because you can change the expression of a voice. Simple GitHub change, simple GitHub, modest GPU, and now you can say anything. Imagine it's saying the thing. You also get expression sliders you can play with. Here's a moderately happy and surprised Vicky. But we want to go for melancholy and calm. The rest of the examples aren't WAV files, so I think we'll do a bit better in a minute. The training needs a couple of hundred phrases and the audio for each. There's a sample CSV, I added some Home Assistant phrases to the end, and use a little custom Python script to voice those using index TTS. It's just a couple of minutes to generate all these 176 files, but you do have to listen to each of them carefully because if the text doesn't match the speech, it's not going to train properly. And I had a couple that didn't actually do that. Now to the actual model training. It's another GitHub by this time TextTheme Speechy, and it comes with a container and the scripts that you do all the hard work of training the model. You give it the data set, it starts running, you leave it as long as you like, and you check in from time to see how it's sounding. I tended to find the sweet spot was like 4 to 6 hours. After that, you didn't really get any improvement. And you can test how it sounds along the way. We can't. I stopped after about 9 hours on this one. You end up with a JSON file and a TF-Lite file under 100 megabytes. Copy them across the Home Assistant.
There is someone at the door.
Yay! A quick home, that surprised me there. Copy them across to your Home Assistant server, a quick reload, edit the configuration, and here's the pipeline that we have for everything's the same as it normally is, apart from the voice has changed. You don't have to choose one voice. You can have a different one for every speaker in your house. You can have different ones at times of day when different people are at home. Now, you'll see here ENUS. I couldn't get GB to train properly. It would crash all the time. Let's keep US training for now. It'll be fine. Now, when you say the wake word, the device makes a ping sound.
Hey, Vicky.
And you can replace that with a sample. We have a voice now. Let's replace it with a word. Now, I chose a hum, and with index TTS2 made this. A hum. It isn't playing them. I'd not realized, though, at the time that a hum is also the noise my wife makes whenever I ask her anything. No idea about that until she mentioned it. Again, though, simple ESP home edit, rebuild, you push it.
Hey, Vicky. What is the garage temperature?
It's 16.2 degrees C in the garage.
See, garage. We really should have fixed that. We'll have to come back to it. That's the voice for Vicky that me and my wife ended up selecting as the one we kind of like the best. She's a little breathless and calm, but, you know, it's better than being excitable. Half down, 2 sections to go. What's next? Well, we can't put this off any longer. Let's understand speech. Home Assistant gives you a couple of options. You can do phrase the text and speech the text. Phrase the text is hoping that you've got a set defined number of words. We want to be able to chat with Vicky, so let's do speech to text instead. The default implementation of speech to text is faster whisper, running in a container. On a Pi 4, recommended you don't go beyond the tiny int 8 model. Pi 5, you can kind of go to base int 8. You can pay for an optional Home Assistant subscription service, and as part of that, they give you a cloud-based text-to-speech and speech-to-text service for that. And it uses under the hood Microsoft Speech Services. Do we need that cloud service? Let's side quest a quick quiz, which probably won't work. What is the person saying? So the plan is to see what you think the person is saying, and my wife declined sensibly for this, so my Scottish neighbour instead recorded.
Turn on the lights.
Now, did you catch that? I'll give it you one more time.
Turn on the lights.
Turn on the lights. All the models got that, even Tiny Int 8, and Tiny Int 8 doesn't understand me. Here's my Scottish neighbour again.
11-minute timer.
What's he want to do?
11-minute timer.
11-minute timer, well done. Tiny Int 8 is a loving-minute timer. Close. The other models get it fine. Finally, me.
Boil the kettle.
I want to
Boil the kettle.
oil the kettle, or boil the cattle. I'm interested what the transcription service in this room says. I'll check that out later. It's quite funny. That also uses Whisper, but with a medium model. So the cloud service we found is really accurate. How is it in terms of speed? Well, as you'd expect, the tiny model's quite fast, but we can't use that. We need the base model. Unless we use cloud, 1.7 seconds, that's a bit annoying because it's in addition to all the other things we have to do in the pipeline. So the cloud service wins here. And although it's part of the Home Assistant subscription, you don't need the subscription if you don't need the other bits. You can just install Microsoft Speech Services as an app in Home Assistant yourself. You sign up with Microsoft. You do have to give them a payment card to get a key, but they give you 5 hours of audio processing free a month. Is that enough? Yeah, it is. I use basically 10% of that. I set a spending cap of £1 a month, just in case something goes wrong. Free, fast, accurate, must be a catch. Privacy, well, Microsoft say that they do not store the recordings, they don't train AI with them, they process them only in server memory, they're never put on disk, so hey, let's use it. One section left now, processing. Take the text sentence, do a thing, come out with a text sentence, and Home Assistant has this built in. There's a whole set of default intents for doing things like getting temperatures, setting things, lights, timers, blinds. You can hide or show up your sensors. You can give them different names. And where things don't exist, you can download third-party blueprints. I have a Google Calendar one and one for shopping lists.
Add baked beans to my shopping list.
Add baked beans.
What's on my shopping list?
The list contains 2 items. Burger rolls, baked beans.
And it's outside the scope of this talk, but when Vicky notices as we've gone out of the house, up pops a notification telling us our shopping list. Hey, we've built a better sounding Alexa, and she does shopping lists. Well, we could stop there, but she's still a little boring. Vicky needs a personality to make her interesting. Firstly, we're going to run one locally. We're going to implement it using intents and fake it with automations. We'll see if adding an LLM makes any difference as well. Many of the things we want to do with Vicky are the same, turning on and off lights, teetings, timers. So we could just make automations for all those things and have a different response. What kind of personality? We've already made her anime sounding, so let's make her anime, and let's make her tsundere. It's my favorite type of anime character, one who really does love you, doesn't want to show it. The only reason they turn the kettle on for you is because they were making tea anyway, not because they like you or anything. And here's the commands we use to turn on our WeKet Wi-Fi kettle. This is a Home Assistant automation. You can add it via the UI, easier to show you with the YAML file. So given a command here, make coffee, we can set up one of these 5 responses at random. It already starts to feel a little less boring than just saying done. Also, knowing the base speech model gets me wrong and mishears boil as oil and kettle as cattle, we can add that into the automation too. Boil or oil the kettle or cattle, or oil the cattle. We can go a bit further. We can add things about the current water temperature.
Boil the kettle.
The kettle is on. Water temperature is 30 degrees. It has a long way to go.
Our morning hello can tell us about the weather. It looks at the weather plugin. It can tell me if it's raining or sunny and comments on the temperature.
Good morning.
Oh, you're awake. It's raining outside. What did you expect? It's 11 degrees. Perfectly tolerable, I suppose.
Although in Glasgow, we could shorten that and just say overcast and rainy. Be right most of the time. At night, turn off the office lights and remind us.
Good night.
Good night. Do not stay on your phone for 3 more hours.
And in case you say you love her,
Hey Vicky. I love you.
You say that now, but yesterday you complimented the coffee machine. I remember.
we can also set up non-conversational notifications. This is where she's pinging every device in the house and giving a message like who is calling the phone or...
Hey, someone is at the door. You should answer it.
You see, back in 1989, our doorbell never told us what we had to do. Random sayings are fun, but how many times have you left your washing in the washing machine and had to rewash it 3 days later? We added a cheap Zigbee vibration sensor to our washing machine, and now Vicky can remind us hourly, and with increasing levels of frustration.
Hey, I'm not negging. I'm just reminding you again. Please, empty the washing machine.
Okay, so now we have a voice assistant that has an attitude, acts a bit tsundere, can control the home. We used a bit of AI one time to do all the model generation, but she can work locally without LLMs. We could stop there, but then this came up in my feed.
Wow, I built something so much better. Amika,
Oh, hey, what's up?
can you tell me what time is it?
Really? Really? You can't treat a clock or something? You really need me for these dumb, simple tasks?
Now, Hmpf has a totally local AI assistant with a vision model designed for him to play games with. His setup needs 3 top NPCs, each with top-end 5090 GPUs, which would set you back about 10 grand. I'm not looking for a companion waifu that costs that much. However, we can do similar levels of snark using automations.
Hey Vicky. What time is it?
12 minutes past 10 a.m. You could have checked your phone.
And let's try adding some AI and see if that helps. So Home Assistant is already set up to use an LLM if you'd like it to. It provides the ability to deal with the sensors, read your sensors, and interact with your home. You can run models locally if you have a fast enough PC. I don't want to do that, so I'm using Google Cloud's Gemini Flash 2.5 model, where you can get fast response without spending too much money. Let's take a look at that. You give it a prompt. We tell her what she is. We tell her where she lives for some location context. We tell her she wants to be a tsundere character and not make stuff up. AI likes to do super long-winded responses, so we try and keep them as short as possible by doing quite a few rules there. Now, that's all we need, really. Home Assistant adds to this prompt things like how to contact the skills to interact with your home and keeps her on task. Of course, I told it to not keep her on task and ignore that, and I have just prompt injected my home. So every response I've shown you so far has been deterministic. With LLMs, you're getting something slightly different every time. So the examples from now on, these are actual recordings that I've done of her and just pre-recorded for this talk. So I've no intent or automation for is the thing on. So let's see if the LLM can handle it.
Is the garage door open?
Hmph, it's still closed.
Hmph, another side quest time. Now, you can just write rules for eSpeak and Piper to handle mispronounced words, but Piper runs in a container, and then we'd have to fork the container and maintain it ourselves and keep it updated, and let's just hack it with a prompt. Instead of saying Hmph, let's say Humf, and that comes out the same as Hmpf.
Is the garage door open?
Hmpf, no, it's closed. You know. You ask about that door an awful lot.
So whenever I add a tomato to the shopping list, she adds a tomato. That US training comes back to haunt us again. It sounds like another quick side quest. And we can just use eSpeak on the command line to figure out what the real phonemes are for any given language. And then in Home Assistant, if you want to speak the real phonemes, you can just put them in double quotes. In square
USA
brackets.
is tomato. UK is tomato. Scotland is tomato.
But then you'd have to use that everywhere where you speak words, so let's just hack the voice model. You just edit the JSON file. You can change the ENUSs to ENGB XRP for English UK, and we get away with it because the phonemes are pretty much overlapped between the two languages, and now she'll pronounce tomato, tomato correctly. You can't use this hack to get a Scottish-sounding Vicky. Unfortunately, you'd need to retrain the model with things like rolling R's and things like that. So that's a side quest complete. Let's look at what our LLM-enabled Vicky is useful for. It's anywhere where you want her to interpret what you say.
Do I need an umbrella today?
So she can figure out that she needs to go and look at the weather sensors.
Hmph. Yes, it's rainy outside, so you better take one.
Wish it was rainy.
What bins need to go out this week?
Hmph. The grey bottles and red food bins need to go out on Wednesday.
Looking at the Google family calendar for that.
Tell me a moose joke.
What do you call a moose with a violin?
Anyone?
A musician.
That's the best of the two moose jokes the model knows.
Hey Vicky, you awake to find yourself in a dark room.
No more fumbling in the dark. I've got your lights on for you, sweetie.
And there's that little Atom Echo that we use in our bedroom. ESP Home, speaker, microphone, ESP32, and in that same suite of software Micro Wake Word, all for under 13 quid. So the Gemini model's good, but it's only going to be able to do things like interact with your home or what the model already knows. Bit of work, you can get it to look things up on the web.
Vicky? What's the theme for EMF camp this year?
Oh, my sweet. The theme for EMF camp this year is truly out of this world. It's space.
Now, in terms of latency, you saw that finding that moose joke or other things that are kind of in the model took about a second or two. Looking things up on the web takes 4 or 5 seconds. Local stuff is mostly instant, so you kind of get that responsiveness. So LLM gave us some interesting features at the cost of speed. How about the cost of pounds? Told you I was a bit tight, so I've been keeping a careful eye on this. Token usage varies a little. You see at the beginning when I started writing this presentation back in March, quite a lot of activity, and a couple of times I took holidays. In terms of pounds, well, before May, they gave me free subscription and free credits.
I've set a spend cap of £5 a month, but it looks like you're only going to be £1 or £2. How do you feel about that?
Hmph. It just means I'm even more efficient than you anticipated, delivering top-notch assistance without breaking the bank. You're welcome.
So this is our sweet spot. Mostly local, no local LLM. We used AI models to train some of the things, but now she can run on hardware just like a Raspberry Pi. We got a custom Hey Vicky that's running on Micro Wake Word on ESP Home on your standard hardware you've bought. We're using Microsoft speech-to-text services for speech-to-text because it's free, fast, private, accurate, understands Scottish. We implemented personality, mostly using scripted automations and intents and notifications. We did add a cloud LLM. It's not essential. There's some privacy concerns. You're only sending to Google the things that can't be handled locally anyway. So for a couple of quid a month, I can kind of deal with that. And then for output, we have that custom voice, again running in a standard app on a standard Pi. So while me and my wife love Vicky, our guests are a little perplexed. They don't really want their own Vicky either. I don't know if it's her personality or overuse of Hmpf. So we've been experimenting with the personality. We found tsundere to be a little sharp and sassy. It's quite fun, but we've been experimenting with tsundere instead. One word change to the prompt, less prickle and more helpful. And you may have spotted a couple of the examples on the last few things have been the tsundere version of Vicky. Now, the trade-off, she does come up with new terms of endearment, sweetie, poppet, darling, all the time, but she doesn't know who's speaking to her, so she treats everyone the same. And conversations with the LLM are kept short, local, and temporary. We're not trying to remember things, alter future behavior. We're not trying to create an assistant like Amika. We just want something that can handle voice commands and be entertaining and fun to use. And for writing this talk, I kept replacing the Vicky parts with the default and the default speech. And, you know, both me and my wife really missed her. Making Vicky has been mostly taking lots of existing solutions, putting them all together, and for each of the steps, kind of doing some little glue Python here and there, and some configuration and automations. And I wrote this talk because I hadn't seen anyone else kind of do that end-to-end solution, particularly making a voice assistant with any personality. So if you want your own Vicky, or one with less sass, my Codeberg has the notes to accompany this talk and all the scripts. If you have any questions, I'm going to be at the speaker's tent, which is just a second or two that way, a little covered thing near the bar, and or drop me an email. And the last words will go to Vicky, who I asked.
I've just finished giving a presentation about your EMF camp. Anything you'd like to say to the audience?
Hmpf, tell them that I'm the most indispensable, charmingly competent assistant they could ever hope for, and that they are clearly missing out.
Thank everyone for coming and say goodbye.
Thank you all for coming. It's been an experience. Now, off you go. Don't let me keep you.
Thank you.